Hello everyone. Welcome to this humble talk. I expected to see like 15 people in the room. And this is pretty awesome, so no pressure for me. Today I'm going to cover, I'm being told I have 40 minutes. I'm going to cover a topic that can probably take like weeks to cover. And I'll try to compress it as much as possible, but after the talk I'll be outside, so come and torture me with your questions to death. Moving forward, so today we shall be talking about continuous delivery and self-healing systems. A topic that has been bugging my mind for, I don't know, maybe since 2012, and I've built some sort of a perfect picture in my head about how these things should work in general. And I've been trying in now 3 different companies to build that perfect picture, and we're finally getting closer to that state. The agenda today, I shall cover briefly what is a distributed system, because some of these things make absolutely no sense for certain software systems. In distributed systems, though, they are the sort of the perfect environment to do continuous delivery and self-healing. The other thing that I'm going to talk about is that I honestly believe that all the boring work that we do as engineers should be done by machines. And many people over the years have been telling me that this is not possible, and almost every time someone says something like that, like a couple of months later, it's already working. So it was a thorny path to a state where I didn't believe that it can be done. My engineers didn't believe that it can be done. But together, step by step, we were getting there. And then we shall cover the 2 major topics, continuous delivery and self-healing. Those are basically, I believe, the 2 places where our systems need to be made robust, so to speak. A bit about me. I'm Alex Popov. I lead the engineering side of Uber in Bulgaria. Currently it's something like 80 engineers, I think, but it's changing very fast. Before that I was with a British unicorn called Skyscanner. Spent some time in the UK, then I've built their teams in Bulgaria. Before that I was in Boston with Kayak. Spent a lot of time in travel. This is probably the first industry where I basically hit a really large volume of end users and started thinking more seriously about these things. And before that, various companies. I've spent about, I don't know, a dozen years of coding myself. All my talks start with that disclaimer, basically. I build the ugliest decks in the world, so please don't judge me. A couple of things that I believe in. I'm a person that likes to laugh and likes to enjoy life and is lazy, okay? And so that's probably what got me into software engineering, because you type a few lines of code and things just happen, and you're just sitting at a I don't know, an armchair with your laptop. But because I like being happy during the day, and I like people around me to be happy during the day. For many years, I've struggled with the notion that when someone makes a mistake, you need to like crush them, basically. Never enjoyed it on both sides of the story. And so in my teams, basically, this is a rule. I don't give a fuck who is to blame, okay? That never solved any of our problems. But an important piece of that picture is also that we cannot just make those same mistakes again and again and again and again, right? And people start blaming when they see that something is failing again and again and again, and nobody's doing something about it. People get pissed, right? And I don't want to get pissed during the day. So we combine this with the fail-fast principle. The fail-fast principle basically says, hey, learn from your mistakes, don't do them again, right? And so every time something fails, I don't care who screwed up. I care how do we make so that we protect ourselves from doing that same mistake again. And machines are really good at this, and this is why continuous delivery and self-healing has been such a big story in my life. The other thing is be lazy. Like I don't like doing something 14 hours a day if I can do that something in 2, right? Learning. Instead of going to someone and saying, hey, you just killed all these systems, I hate you, you can just say, hey, how do we do so that we learn from that experience? And often when I hear someone say, hey, my teams never fail, I'm like, oh my God, that guy is not for my team. Because failing is a natural part of our lives. We always fail, we shall always fail. There's no perfect system. And we need to learn how to cope with failure, not try to prevent it. If we don't fail, we don't learn. It's as simple as that. And the other thing is that we're spending like 8, 10, sometimes 12 hours a day in the office. We need to enjoy that time. That's like 40+% of the time that we have on this earth. And if I've learned something over the years, that is that the most precious commodity that we have is not gold, it's not money, it's not, information, some people say. I claim it's time. You cannot pay back and buy time. So moving forward, distributed systems. My first touch point, so my first, 10+ years of my engineering experience were on the low level end. I was coding in the kernel, I was coding in the user space, but mostly related to Java virtual machines and operating systems. And I did a lot of embedded, and back in those days, like in the early 2000s and before that, embedded was properly embedded. It's not like today where you have like gigahertz processors and gigabytes of memory. And everything was scaling vertically. And then I changed the field and suddenly ended up in an environment where things were extremely different. There were millions of users, there were some machines that were running who knows where, and they were constantly failing. And so I had to learn fast that engineering in that kind of environment is very different. So internet economy is constantly changing, but very, very different field from, say, embedded or graphics or some other fun stuff. But these systems have a couple of really cool capabilities. First of all, they scale very easily. So you need to double your traffic in like an hour. You can easily have 2 times more machines to handle that traffic. They're extremely responsive, so you cannot afford someone to sit on their phone and wait for like a minute for you to display some information, right? They are very reliable. So something breaks, nobody cares. There are like 1,000 pieces that are doing the same thing in the same system. And the other good thing is that it's distributable. So I no longer care if there will be a volcano under my data center, right? 1,000 kilometers away, I have a total replica of my environment. And these capabilities allow us to do some fun stuff. And the first thing is that we can very rapidly prototype. So you write 10 lines of code. I've seen companies where I never went that far into the extreme, but they were not doing testing. They were not writing good code. They were not following like 9 out of 10 principles that we follow as good engineering principles, because they were compensating with one system in their environment. And that system was their monitoring system. And that monitoring system was catching up problems very fast and removing those problems very fast automatically. And I had, when I saw that, I'm not going to mention the company because, as I said, I have mixed feelings. But when I saw that, I was shocked. I was like, how is this possible? You're copy pasting code and you're writing in a language that is so archaic that nobody really uses, that nobody really knows that anymore, and yet those systems work. But that was a breaking point for me where I started thinking, hey, if this crappy engineering organization can have close to 100% availability of their end product, and they have millions of users, The other thing that pushed me into that direction was the fact that no matter how many of the pieces that I'll show you in a second of these systems we do, we always end up at the point where a human is looking at a monitor and is taking some action. And usually that's a boring action. And then I'm thinking, well, the machine is way faster than me. The machine understands time series way better than me. So why am I doing this? Why is not the machine doing this? Sorry about that. So the other thing is that if you lead people, you know that you never have enough engineers. You always ask for more and more and more. And so I was asking myself, well, if I need 10 times more engineers, how do I get them? And the answer is you can't. This is a very inert process. You need to find the right people. You need to convince them to get on board. You need to pay them the right salaries. And there's another piece that says, well, these people do these things for me, and they have a cost. So are they producing more value than their cost, right? But scalability is the big problem here. You cannot just 10x your team in like a month. And so I was thinking, how do we do 10x more work with the same team? And this helps. I'll explain why. Moving forward, so continuous delivery consists of two pieces, basically, of continuous integration and of continuous deployment. And so to have that, you need a couple of baseline actions that the system needs to take for this to happen. Ideally, the goal here is that, unlike in the past, we are not releasing every 6 months. Releasing every 6 months has horrible consequences. So we want to do that on a daily basis. We want to do that on a weekly basis. It doesn't matter, but it shouldn't be fixed to a date. And you can have continuous delivery without any of what you will see today here. What I'll show you today helps you do that in a seamless fashion that is not pissing off anyone, right? People don't do boring stuff. But in order to have a continuous delivery system, you need to have a testing framework. You need to have something that deploys the code changes that you're making into production. You need to have monitoring that basically tests if what you're putting in production works. And you need to basically react if something goes wrong. And then you repeat that process again and again and again. As I said, some people consider continuous delivery rolling out something once a week. Some people consider continuous delivery rolling out 5 times a day. Continuous delivery, though, is not a silver bullet. There are systems that are not suitable for that type of process. I wouldn't do continuous delivery on a space shuttle that I just launched into space, okay? Or a robot that is operating someone. This is the usual pipeline of what a developer does when they make a change. They write a code, they write tests for that code, then we do code reviews. These help, I believe in them. And we use various tools like your IDEs, and we use Fabricator, a lot of people use Jira, something else. And then we roll out those to the production systems. Now, we use a system called udeploy at Uber, but I'm sure that you've heard of Jenkins and various other ways to do that. Then if something goes wrong, we either debug the errors or we tune performance, and then we consider that the change is in production and it works. And then we monitor those systems, because there's no guarantee that during that process of deployment we've caught everything. I've seen systems that degrade over months. Once we catch something, though, we need to have tools to also quickly analyze what has happened. So instead of digging into the code or someone else's code for days until you find a bug, it's best if a tool tells you, hey, this is where the thing is failing, this is why it is failing, this is how you can fix it very fast. And for that, you have the monitoring that basically tells you what is happening with the system. You have tools like Jaeger. I think Jaeger is open source. Some of you may know it. That basically does flow profiling, so to speak, end-to-end flow profiling. And the other piece is where is the system actually failing. A few baseline things that you need to have in place in order to do what I've just described. First of all, metrics. Every time I see someone building something and not having the right metrics, I'm truly scared, because people don't know what is happening with their systems. They don't know what is happening with the business. They don't know what is happening when they deploy 10 lines of code in production. And this can have some scary results. I've worked on products that have 0.5 billion users. So you can imagine how many people you're impacting if you do something wrong. Monitoring based on those metrics. And, well, I'll get back to that, but metrics have various kinds. A lot of us probably have good operational metrics. That's not enough. I'll get back to that. Another thing, basically something that tells us, hey, I've set these thresholds. If my time series go outside of those thresholds, please let me know, because obviously something is not going right. Now, things that help are containers. Containers have changed the world dramatically, I believe. Back in the day, we were doing virtual machines. Before that, we were using actual physical hosts. It was a freaking nightmare to move at speed when you have those. And it was a huge waste of resources as well. Utilization was very low. Smart load balancers. So load balancers, I'm pretty sure many of you are familiar with what that is, but they basically route traffic to different workers. The first load balancers that I've used were basically doing just that. They were just saying, hey, I'm going to send 1% of the traffic to machine 1, blah, 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 and 100% of the traffic to machine 100. And this is simple, easy to put in place, and a lot of people have that. This is quite not enough if you don't want to do a lot of that hard, boring stuff related to self-healing and continuous delivery. Ideally, you want your load balancers to speak to a lot of other systems, to your A/B testing frameworks, to a bunch of things. We shall cover that later. Auto-scaling helps. So when you have a pool of machines and you get hit by surprise by traffic that you cannot handle at this point in time, bad things happen if people have to take care of that. At the same time, when you have containers and when you have systems that are monitoring that, the systems can very easily spin new instances and add workers that will cover for that. In most cases, you may get a degradation of that traffic because auto-scaling happens with some inertia, I would say. It's not an instant thing. But you don't go down, and availability is everything in the world of internet economy. Feature flagging helps. It helps with your A/B testing. It helps with making those load balancers work the way you want them to work. A couple of principles that we follow. We say that, well, we didn't say that. Someone at Amazon said it when they heard it from someone somewhere else. But you'll be able to run it. So in our organization and across different companies, this has been the de facto standard for me. We don't have QAs, we don't have release engineers, we don't have SREs, we don't have security guys. We're avoiding at all costs ending up with having the this is someone else's problem syndrome. In my teams, that is not acceptable. Engineers are responsible for setting up their infrastructure, for setting up their databases and storage, for setting up their deployment environment, for setting up their alerting and monitoring, for taking care of their security, and all of that. Can they all be experts into all of those fields? Certainly not. And this is where we talk about horizontal expertise support. We still have the SRE guys. We still have the security guys. We still have a bunch of specialists in different systems. But they teach my engineers how to do things right. They don't do that for my engineers. Okay? The end goal, though, is for developers to code, though. The one thing that the machine still can do for us is to code, to solve a problem. As I already mentioned, a lot of roles are, I wouldn't say made redundant, they were changed in terms of a role. Some are redundant. There are no QAs in my teams, for example. We believe that automated testing works much better than people testing. Back in the day, I wasn't bored with that belief. I had a lot of teams with a lot of QAs, and this was a huge stopper for us to have proper continuous delivery. Because one, engineers say, hey, someone else will test that code, I'll just dump it into a code repository. Then that someone starts doing that and spends sometimes days because they don't understand what is happening. They then go back and forth. They then send it to some release engineers who are saying, hey, you missed the deadline, now you will wait for the next release. This is fucking ridiculous. It might be like 2 lines of code that are critical for the business. I claim, though, that people are really not good at doing a number of things. When I hear someone tell me that they're building something, or that they are deploying something, or that they are testing something, or watching dashboards to see if what they deployed is working, that's crazy. Like, these people are super smart, and they're spending their time to do trivial stuff that doesn't require their engineering competencies. What are the pieces that enable having all of this? Having a test framework, I believe, is important. As I said, there are organizations, and I've seen this, that don't do tests, and at the same time, their systems are pretty reliable. It's your choice. I don't like that. Logging, of course, because without it, not only people are deprived of the opportunity to find problems, we are taking that to the next level, where machines are actually analyzing the logs and are taking action based on those. If you don't have that data, it's not possible to make the machine do that hard work. Infrastructure, obviously, containers, as I said, help, but we have the tools that enable our engineers to set up their environments, and that happens once. So once someone says, hey, these are my clusters, this is my storage, this is my network, these are my resources, it's done. Because then they configure things like load balancing and rate limiters and things like that, and they're done. From that point out, the machine is responsible for handling everything in those systems. So all of those systems that you see here need to have interfaces that allow code to interact with them or to receive data from them. Okay? The other pieces, I'm pretty sure all of you are familiar with all this: auto-scaling and load balancing, monitoring and alerting, deployment and rollouts. A/B testing is good. I love the frameworks because it turned out they can be used for a lot of things, not just A/B testing. Load testing, like, I'm pretty sure that Chaos Storm is probably something that is unfamiliar to most of you, but you've seen Chaos Monkey and things like that. Test tenancies. So there's the other piece where over the years I went in a bit into the extreme when I was saying, hey, everything can be run on 0.5% of the traffic and we can test it, and then if it doesn't work, that's fine. We shall roll it out, fix it, deploy again, then increase that percentage of traffic. If it breaks again, we shall fix it, put it in production again. Then I've stumbled on environments and products that do not allow that. Like at Uber, my teams, for example, are building the tax calculation engine, and you can imagine how, I don't know, about 20+ million transactions of money every day can be affected by that, because we calculate the wrong tax, the money loss is something that we can live through. But then a regulator comes in and says, oh, we stopped the service in our country because you're calculating the wrong taxes. And so this can be extremely damaging for the business. So having test tenancies and an environment that doesn't impact production and test into that environment is great. We are doing that, and I'll come to that point probably very soon. I don't believe in integration environments. I don't believe in staging environments. I don't believe in pre-production environments. I've seen all of this, and it never really guaranteed in my past that when something ends in production, it will work in production. And so I've often asked the question, why are we spending all this money for all this infrastructure if that is not solving our problem? And we went quite extreme at Skyscanner like 5 or 6 years ago, when we said we shall deploy directly to production. Now, this is not a space shuttle. Again, I'm saying those systems allow error. But at Skyscanner, we said, fine, we shall deploy directly to production, and we shall deploy in such a small traffic, and we shall have such a good monitoring system that whatever breaks, SelfHealing will compensate for it. The end user is not going to see it, but we will know, without having alternative environments. And it worked quite well for us. So I'm pushing at Uber to do something similar. Currently, Uber basically is splitting their hardware into a test tenancy and a production environment. And the test tenancy really can be just feature flags. It's up to the software to decide whether you're impacting the real world or not. It shouldn't be physical machines. Having a good continuous delivery system can prevent you from a lot of trouble and do a lot of work for you, but ideally I want to see my engineers code. I don't want to see my engineers deal with boring stuff that doesn't require their engineering competencies. So the day at one of my teams for an engineer looks like this. They take a ticket, they start coding. It may be like 10 lines of code. They put those 10 lines in code in place, they push, and they forget. And then go to the next ticket. Everything else should be a problem of the system. So at that point in time, the Git hooks are basically taking this, signaling to udeploy. This is the system that we use. And it takes care of testing everything. If it breaks, it breaks. The developer is just getting an email that says, hey, things broke here and I stopped. They don't need to go to another system and to check what is the status of my deploy. They're also getting those alerts into their team channels. So it's linked to things like Slack and UChat, Uber, etc. But let's say that the testing goes well. You run the unit tests, you run the integration tests, everything's fine, you drop it to production. Then we have two scenarios here. The first scenario is we do blue-green deployments. So basically it says, I'm gonna start like 10 containers that will run that new version of the software that I just built and monitor that over time. This is what is happening right now. I don't like that. In the past, we've had something smarter, something that was saying, hey, during that build phase, I'm going to wrap your code into a feature flag. Automatically, you don't need to do anything. And then basically I'm gonna tell my load balancers that only a fraction of the traffic, and this is where I said that the A/B testing frameworks come in because they give you that functionality for free. So if you already have a A/B testing framework that has a programming interface, whatever it is, it's doable and easy. But then you say, hey, run this traffic with this feature flag, and it runs on the same machines, it runs without impacting your production if you choose to, etc., but it runs there. And the other piece here is that the load balancer is capable of very fine-grained control of the traffic that you want to put into such an experiment. If you have only 4 containers that are serving a very small service, and you do blue-green deployments, you're impacting double-digit percentages of the traffic. And that's not okay. If you have feature flagging, you can say, on these 4 containers, I want only 0.1% of the traffic to be impacted by that new change. And that's fucking awesome. It builds data for you to say with statistical significance, yes, it works or it doesn't work. It may take days. It's up to you to decide, though. You have the flexibility to use that. But once that happens, it gets rolled out gradually. You increase the number of containers that are running the new version, or you increase the traffic that is running through that new version. In the first case scenario, you're done at this point. Basically, all your containers were replaced with the code with the new version. In the second scenario, you have at the background, you have work that needs to remove that feature flag and basically make it the main. In both scenarios, if something breaks, an alert goes to the developer and says, hey, I broke at this stage, these are the reasons, with all the necessary data for them to take action quickly. It's up to the developer, though, to decide whether they will continue coding the new thing that they just started, or to go back and see what's happening, and when. Okay? And so that allows us in good days to one developer to deploy 3, 4, 5 changes into production. So that leads to an environment where developers are obviously doing what they're good at instead of boring stuff that is just important. It's business as usual. And it makes sure that those systems are fairly reliable. It doesn't solve all problems. As I said, there's no perfect system. But it's 100 times less often happens for these systems to break when we do changes. At Uber, because of the traffic, we try to maintain 5 nines of availability. And it's not easy. Chaos is out there, though. The universe is always hostile. I keep repeating that in my teams. Every time you design something, you need to consider the fact that the universe is going to try to break it. And so there are a couple of things that you can do. One, you do good designs that are robust and will not allow these problems to affect us or the end users or our stakeholders. And 2, you build systems that are taking care of those problems. No matter how much time you spend into thinking of how to build something, you will make mistakes over time. We are humans. So this is where self-healing comes in. Initially for me, the continuous delivery piece was like the thing that I was heavily focused on, and I was thinking this is where I need to stop investing time with my engineers. And then we moved into a different world where my engineers were now complaining not about the fact that they are spending 3 hours a day deploying 3 changes, the fact that they're waking up at night. And so we started looking into what is happening. And it turned out that 8 to 9 out of 10 times, the things they wake up at night for are bullshit. They can either be taken care of by a machine, or they are someone else's problem, or a completely irrational reason to alert someone during the night. And so it's a combination of things. Self-healing only helps you solve the trivial problems in production. But as I said, most of the problem turned out to be trivial. A bunch of machines have failing memory. And so the containers on them are failing. But they are good enough percentage to affect our metrics, to cross the thresholds, to trigger alerts. Then people wake up at night, kill those machines, and go back to bed. Now, it took them probably half an hour to wake up and find out what is happening. Another 5 minutes to kill those machines and leave the autoscalers to bring up new containers or fail over to a different data center. And then they went to bed. And it took like 40 to 50 minutes for a problem to be fixed. If a machine could detect that, it can react in probably less than a minute. So we had 40 minutes in which our customers were affected. It's not good for my engineers. It's not good for my customers. It's not good for me because in the morning they come to me and say, whoa. Okay? So we started building systems that will react to a lot of those. We basically clusterized the problems that we have and we said, how can we fix that? How can we fix it? Pick the low-hanging fruits, fix things. A lot of the time it turns out that a system that is an upstream dependency is failing, and then all of the systems that depend on it are failing as well. Guess what happens? 10 or 15 engineers across the world wake up to just see that it's not their fault. And just one of them basically says, oh shoot, I need to take action. So we built something called staging alerts, something that basically tracks down what is happening through the flow of the data and says, hey, this is where the problem is. A lot of systems will break after it, but I'm not going to wake up those guys. If someone decides to wake them up, if there's a more complex problem that I can detect, whoever woke up is going to wake someone else up. There are other things that you can just do in your code, runtime things. Do validations, rate limit, retry. I've seen large organizations call our APIs once, and they say, oh, we've called you, and about 1.5% of all the calls to your systems are failing. And I'm like, okay, what happens after the first retry? And they're like, what retry? And I'm like, let's do 3 retries. Let's exponentially increase the time between them, and then decide that we have a failure here. As I said, though, no matter how good we become at building those self-healing systems, and there's no silver bullet here. As I said, you need to look into your logs and decide what is waking you up. You need to do your postmortems and clusterize your or classify the problems that you're having. But the universe is always going to be hostile, no matter what we do. And so we should always wake up. Again, I said it before, but the question here is, how do we wake up as well, almost never. Okay. So as we were building, as I said, for me there was a transition period where I started thinking about the continuous delivery. I was thinking about the continuous delivery, and I transitioned into thinking about self-healing, because it turned out that to solve the self-healing problem, we need a bunch of systems that are already there. And so just using them to solve that problem makes solving that problem very cheap in terms of investment of time, in terms of thinking, in terms of having to deal with certain problems. You have your health checks anyway, right? You have good operational metrics. One thing that I see across organizations is that they don't have good business metrics. So I take a team, and first thing I ask them is, how do we know these 10 lines of code that we just changed, how are they impacting the business? And I often hear the answer that, oh, we are so deep back-ended, we cannot impact the end user. This is bullshit. I've seen 12 lines of code drop the revenue of a billion-dollar company with 0.8%. 12 lines of code. Nobody expected that we shall have impact on something like that. It was crazy. It took us like probably 4 or 5 days to come up with a theory why is that happening. We never really knew for sure. But these things happen. So you need to have both the business and the operational metrics. It's not enough to alert and take action only on the operational metrics. The other thing that is good to have in place is obviously the infrastructure monitoring. So your systems need to be ready for a failover. Flip the switch and start working from a different data center. It may lead to a degradation or temporary degradation of your services, but it should not lead to a downtime. I've seen en masse how people flip the switch and then system starts to break. And so we started flipping the switch in a controlled fashion every couple of weeks without telling the developers. Okay? We just fail over and see what happens. Same thing you do with Chaos Monkey when it starts killing containers, right? Alerting the machines. As I said, a lot of these systems can talk to each other. You don't need to involve the engineers. Engineers are people. They are slow. They're slow. They don't see fine-grained details in the time series. They don't see patterns in the time series. Machines do that better. Analyzing the flow. As I said, if you know what is happening end-to-end, it's so much easier to just identify a problem and take action. It may be someone else's system, And your machine can auto-heal someone else's system because it's basically super easy. It just needs to kill a couple of containers because they're leaking or their memory is busted or something else. And alerting people the smart way. I was already telling you about staging alerts, where you say, hey, 15 people just woke up, but only one of them has a problem with their system. All of the others are just impacted. And the other thing is, and I'll finish with this, systems are not the solution for all your problems. I've seen teams where their SLAs were just ridiculous. Someone needs to get a receipt from their trip at Uber, and someone comes and says, well, your SLA or your SLO is to basically deliver that receipt 1 minute after the trip. Why? There's no regulation that says that. None of our users are complaining that we are delaying their receipts. And so we ran a very disruptive experiment. We said, I'll just deliver all receipts for a day, 8 hours after the trip has happened. Do you know how many complaints we got? And then my SLA just turned from 10 minutes to 8 hours. And we still haven't seen anyone complain about it. Now, there are places where the regulation says otherwise, and there we have different SLAs. But sometimes it's up to us to make sure that those systems are not killing us, right? So hopefully I managed to convince you that machines are really good at building and deploying. People don't need to do that. Monitoring, people don't need to do that. Kill and create containers or VMs or whatever you use, people don't need to do that. Reroute traffic when something goes wrong, people don't need to do that. And wake someone in a smart way without having to wake up people. And the end result, no matter how controversial it is that our systems are more stable, our users are happier, and my developers are happier, which makes me happy. So with that, I'm going to wrap up. Thank you.